Good morning, everyone.
Good morning, sir.
Good morning. So today we'll try to derive two derivations. So which should be asked frequently. Only three derivations are there. As I told you, one we have derived in the last class. Today's class will be deriving the two derivations. So where it says to derive the optimal pressure. See, this optimal pressure ratio would be derived for ideal Brayton cycle as well as for the actual Brayton cycle. Actual Brayton cycle is one where you get the values of NC and NT. Okay, NC is nothing but eta C is nothing but efficiency of a compressor, and eta T is nothing but efficiency of a turbine. Okay, so both the things you will get. So once both the things are get, then you can know that this particular thing is with the actual Brayton cycle. Now for the normal Brayton cycle, which is ideal Brayton cycle, we will be having something like this. Okay, I'll just draw the Brayton cycle firstly, or else I'll pick the from the previous one. Okay, no, I shall just draw once more. Okay. Both PV and TS diagram you have to draw. Come on, draw all of you. Draw the Brayton cycle first. So PV, and other you have to draw the TS diagram. Okay. PV diagram is something like this. From here to here it's a curve. And here to here it's a curve. Okay. So this one is state 1. From state 1 to state 2 it is adiabatic compression. Pressure gets increased. 2 to 3 you're adding up heat. And 3 to 4 it's expansion in the turbine. And 4 to 1 is a heat exhaust. The same thing in the TS diagram. Isentropic compression, so entropy remains constant. From there, going like this. Then you are coming back like this. So it is 1 here, 2 here, 3 here, and 4 here. Okay. So these are the PV and the TS diagrams for the Brayton cycle. Okay. So just write the same thing. The above two figures represent. I want you to take the notes parallelly with me. There will be no extra time given for you to take the notes. So parallelly you have to take the notes along with me. Okay. I will be checking randomly whether you are writing the notes or not. So make sure you take it. Because since the derivation, you have to solve it also. Represent the PV and TS diagram of ideal Brayton cycle. So the above two diagrams represents the PV and TS diagrams of ideal Brayton cycle. Okay. Now for Brayton cycle, okay, work done in a cycle is given as now. How many work done are there in the Brayton cycle? How many work done are there?
Two.
Very good. 2. One is the compressor work, which is used to increase the pressure, and other one is the turbine work, which is used to expand. So same thing I will be writing here. W net is equal to WT plus WC. I told you in the last class, how do you calculate WT? MCP into temperature difference. That temperature difference also, how will you calculate? For work it is, and for heat it is. Remember or not? I told you in the last class. ಹೇಳಿದಿನಲ್ವಾ? ಹೇಳಿದಿನಲ್ಲ. For work it is, I'll just pick this up. Copy. For work, for work it is initial minus final. Now, ಇಲ್ಲಿ ನೋಡಿ 3 to 4 ಟರ್ಬೈನ್ ವರ್ಕ್ ತಾನೆ, ಕರೆಕ್ಟಾ? ಇದರಲ್ಲಿ ಇನಿಷಿಯಲ್ ಯಾವುದು, ಫೈನಲ್ ಯಾವುದು? Whether 3 is initial or whether 4 is initial. Which one is initial state? 3. And which one is final state? So 3 is initial state. Illinda start agi illige baruvanthaddu. Hauda? So this is the initial state and this is the final state. Okay? So that's why I would take it as MCP. Turbine work helbekadre, for work it is initial minus final anta helde nanu. Initial enu T3 tane. So T3 I would take it as minus final. Final is T4. Now all of you tell me for the compressor work, which is again MCP into compressor work ಹೇಳಿ. ವರ್ಕ್ ಅಂತಂದ್ರೆ ಇನಿಷಿಯಲ್ ಮೈನಸ್ ಫೈನಲ್. ಕಂಪ್ರೆಸರ್ ವರ್ಕ್ ಬಂದ್ಬಿಟ್ಟು 1 to 2 ಆಗುವಂತದ್ದು. So it is going from 1 to 2. So which one is initial and which one is final? Whether it is T1 minus T2 or whether it is T2 minus T1?
T1 minus T2.
Very good. So it is T1 minus of T2. Inadru common tekkoboda? Anything can be taken as common here.
MCP.
Very good. Take it common. So it is MCP into T3 minus of T4 minus plus it is plus T1 minus of T2. Next, MCP into nanen ಮಾಡ್ತಾನೆ T3 minus of T4 as it is ಇರಲಿ. ಇದನ್ನು T2 minus of T1 ಮಾಡ್ತಾನೆ. If I want to do so, what should I do?
Minus common.
I have to incorporate a minus sign there. Now, if I consider the above for a unit mass ಅಂದ್ರೆ ಏನು? Mass 1 ಅಂತ ಅರ್ಥ, 1 kg ಅಂತ ಅರ್ಥ. So considering the above for what? Unit mass consider ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? M value 1 ಆಗುತ್ತೆ. So W net is equal to just CP into T3 minus of T4, okay, minus T2 minus of T1 is tight. Next, W net is equal to CP into, illi nodi, all of you observe this, T3 minus of T4 alli I want to take T3 as common. Have taken T3 as common. So if I take T3 as common, what would remain here? 1
minus T4 by T3.
Excellent, Kana, excellent. So it is 1 minus T4 by T3. Similarly here, I would take T1 as common. So it is T2
by
minus
T1.
T1 minus, exactly. Okay, next. But by the definition of the temperature ratio, TR is equal to, last class ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ ನಾನು, TR is equals to T2 by T1, that is also equal to T3 by T4. ಆಯ್ತಾ ಕುಕ್ಕರು? ಆಫ್ ಮಾಡಮ್ಮ ಅದನ್ನ. ವೆರಿ ಗುಡ್. ಸೊ ಡಬ್ಲ್ಯೂ ನೆಟ್ ಈಗ ಏನಾಗುತ್ತೆ, T4 by T3, T2 by T1, TR ಆಗಿ ಬರ್ಕೊಳ್ಳಿ. ಕರೆಕ್ಟ್ ತಾನೆ? ಬರಿಬೋದಾ? T3 into 1 minus T4 by T3, can I write it as TR?
One by TR, sir.
1 by TR.
First ಗೆ
Very good. Excellent kana. So T3 by T4 is TR. This is 1 by TR. Very good. Minus T1. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ TR ತಾನೆ? Very good. So ಇಷ್ಟ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಎಂತ ಮಾಡೋದು? So W net is equal to CP into T3 into 1 minus TR ನಾನು ಮೇಲೆ ಕಳಿಸ್ತೇನೆ. So it is TR to the power of -1 minus T1 into TR minus 1. Close ಮಾಡ್ತೇನೆ. And I would take this particular equation as equation number 1. Okay na? Next. ಇದು ನೋಡಿ, the condition for maximum specific output is, so there is a condition for maximum specific output. ನಿಮ್ಮ work output ಚೆನ್ನಾಗಿ ಬರಬೇಕು ಅಂತಂದ್ರೆ ಟರ್ಬೈನ್ ಇಂದ, there is one condition. What is that condition? That condition is d by dtr of w net, illandre just w net anta baritene, should be equal to 0. Now I will be using this particular condition to get the maximum output. So now it is d by dtr of w net. ಈ w net ನ ನಾನು ಇಲ್ಲಿ ಕಾಪಿ ಮಾಡ್ತೇನೆ. And this should be equal to 0. Okay. Now, differentiation ಬರುತ್ತಾ ಎಲ್ಲರಿಗೆ? So TR in the differentiation ಮಾಡಿ ನೋಡುವ. CP into CP is common for entire thing, isn't it? CP is common. ಈ second expression ಅಲ್ಲಿ T3 ಒಂದು constant ಆಗುತ್ತೆ. Okay. So differentiation of 1 is what?
0.
Minus TR to the power of -1 differentiation, x to the power of n differentiation. It is n into x to the power of n minus 1. ಕರೆಕ್ಟಾ? ನನಗೆ ಮ್ಯಾಥ್ಸ್ ಅಷ್ಟು ಗೊತ್ತಿಲ್ಲ, ನೀವೇ ಹೇಳಬೇಕು.
Yes sir.
ಕರೆಕ್ಟಾ? ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಮೈನಸ್ ಆಸ್ ಇಟ್ ಇಸ್ ತಕೊಂಡಿದ್ದೀರಾ. x to the power of n is n into x to the power of n minus 1. n into
+1 into
n into x to the power of n minus 1. ಕರೆಕ್ಟಾ? ಕರೆಕ್ಟ್ ಮಾಡಿದೀನಾ?
Yes sir.
Minus T1 into TR differentiation 1 minus 0. ಕರೆಕ್ಟಾ? That is equal to 0. Right? ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ನೀಟಾಗಿ ಬರ್ಕೊಳ್ಳುವ. CP ಇಂಟು CP ಆಚೆ ಕಳಿಸಿದ್ರೆ 0 ಆಗುತ್ತೆ ತಾನೆ. ಶುಡ್ ಐ ರೈಟ್ CP again and again?
No.
So CP is 0 there. Next, what else is remaining? I'll just write T3 minus into minus plus ಆಗುತ್ತೆ. ಕರೆಕ್ಟಾ? Then into TR minus 2 minus 1 minus 0 ಬಿಟ್ಬಿಡೋದು ವೇಸ್ಟ್. So T1 is equal to 0. ಕರೆಕ್ಟಾ?
Yes, sir.
Yes, sir.
ಕರೆಕ್ಟಾ? Now, ಈಗ send T1 to the either side. Can I write it as TR to the power of minus 2? It is equal to T1 divided by T3.
Yes, sir.
Yes, sir.
Right? Now, TR is equal to T1 divided by T3 whole to the power of 1 by 2.
Yes, sir.
Correct unta? Next, again. ಇಲ್ಲಿ ನೋಡಿ, again ಏನಾಗುತ್ತೆ? T3 by T1 is nothing but your TR, right? Correct?
Yes.
Yes.
And in the last class I have said TR is equal to beta to the power of gamma minus 1 by gamma. Correct? From
Sir, how
previous
it is
derivation.
T3 by T1 is equal to TR?
1/2 ಕೆಳಗೆ ತಗೋ, ಇದು ಇನ್ವರ್ಸ್ ಮಾಡು.
ಏನಾಯ್ತು?
Sir, T3 by T1 equals to TR ಹೇಗಾಯ್ತು ಕೇಳಿದ್ರು?
ಇದಾ?
ಹಾ.
ಇಲ್ಲಿ ತಗೊಂಡಿದ್ದೀವಲ್ಲ ನಾವು. ಇಲ್ಲುಂಟದು.
ಸರ್ ಇಂಟು ಆಗ್ತದೆ. T1 into T3 is equal to TR ಆಗ್ತದೆ ಅದು.
ಇಲ್ಲ ಕಣ. TR equal to T2 by T1 that is equal to T3 by T4. ಕರೆಕ್ಟಾ? ಈಗ ನಾನು ಇದನ್ನ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? T2 by T3 equal to T1 by T4.
ಓಕೆ ಸರ್.
ಕರೆಕ್ಟಾ? ಆ ರೀತಿ ತಗೊಂಡದ್ದು. ಈಗ ನೋಡಿ, ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳ್ತೀನಿ ಕೇಳಿ. ಈಗ TR is equals to beta into gamma minus 1 by gamma. ಇದು ಗೊತ್ತು ತಾನೆ? ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡೆರಿವೇಶನ್ ಮಾಡಿದ್ದು. ಕರೆಕ್ಟ್?
Yes, sir.
Now, when I add optimal for the TR, even beta would be optimal. Correct? When I don't add optimal here, even beta would be not optimal. For example, if I add optimal here, that is TR, optimal anta add ಮಾಡಿದಾಗ, even beta would be optimal value. If I don't add optimal, like as in case of this particular expression, even beta would be a normal pressure ratio. If I add optimal temperature ratio, even beta would be optimal. Artha aita? Got it? So in such case, now this particular TR ಏನಿದೆ ಅಲ್ಲ, so ಈ TR ನಾವು ಕಂಡೀಷನ್ ಹಾಕಿ ತೆಗ್ದದ್ದು ವ್ಯಾಲ್ಯೂ D by DTR is equal to W net is equal to 0 ಅಂತ ಸ್ಪೆಸಿಫಿಕ್ power output ಜಾಸ್ತಿ ಮಾಡ್ಲಿಕ್ಕೆ this is the TR. So when I have calculated this particular value of TR using a condition like this, I am in a position to call this as an optimal TR. Getting it? I am in a position to call it as optimal TR just because I have used this particular condition here. So now TR optimal idre, can I write it as beta optimal to the power of gamma minus 1 by gamma? Can I replace this?
Yes, sir.
So So now I will be replacing it by beta optimal whole to the power of gamma minus 1 by gamma, that is equal to ah, this is T3 by T1 na, T1 by T3 na. ಇಲ್ಲಿ ಏನೋ ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ. ಫ್ಯಾನ್ ಏನ್ ಬೇಡ, ಅದು ಡಿಸ್ಟರ್ಬ್ ಆಗುತ್ತೆ. ಇದನ್ನ ಹಾಗೆ ಇಡುವ. ಓಕೆ, TR whole to the power of minus 2 is equals to T1 by TR. ಓಕೆನಾ? So 1 divided by TR square is equal to T1 by T3. Okay, iste kana idin karma. So now, if I change this to positive symbol, TR iddadana positive square agi madidre, minus iddana positive agi madidre, can I change this to T3 by T1? Yes?
Yes.
Yes,
So
sir.
once that is done, now TR optimal is equal to T3 by T1 whole to the power of 1 by 2. ಈ 2 ನ ಆಚೆ ಕಳಿಸಿದ್ರೆ 1 by 2 ಆಗುತ್ತೆ. Now TR optimal is what? Beta optimal into gamma minus 1 by gamma, that is equal to T3 by T1 whole to the power of 1 by 2. Okay. Now T3 by T1 ಏನು?
TR.
TR. So it is gamma minus 1 by gamma, that is equal to TR whole to the power of 1 by 2. Now ಈಗ ನನಗೆ ಫೈನಲ್ ಆಗಿ ಬೀಟಾ ಆಪ್ಟಿಮಲ್ ವ್ಯಾಲ್ಯೂ ತೆಗಿಬೇಕಂತಂದ್ರೆ TR whole to the power of, I have to transfer this gamma minus 1 by gamma to the either side, RHS. Then what it would become?
Gamma by gamma minus 1.
So gamma divided by, already 2 is there, gamma minus 1. Correct unta? Correct unta?
Yes, sir.
So now this is the required expression for the optimal pressure ratio in case of an ideal Brayton cycle. So just write that is the required expression for optimal pressure ratio for maximum specific power output of, ಇದು ನೋಡಿ ಹೈಲೈಟ್ ಮಾಡ್ತೇನೆ, it is ideal Brayton cycle. Ideal Brayton cycle. Any doubts in this particular derivation? Any doubts?
Sir, starting
Starting ಏನಿದೆ
Yeah,
ತೋರಿಸ್ಬೇಕಾ?
sir. Starting in the
ಕ್ವೆಶನ್ ಅಥವಾ ಆನ್ಸರಾ?
starting answer.
All of you in the next few minutes mark your attendance in the attendance sheet.
ಸರ್
ಹಾ
ಸಿಂಕ್ರನೈಸೇಷನ್ ಎರರ್ ಅಂತ ಬರ್ತೈತೆ ಸರ್.
Sir, can
ನಿನ್
you show
ನೆಟ್
question?
ಏನ್
ನೆಟ್
ಸರ್?
ಕನೆಕ್ಟ್ ಆಗಿರಲ್ಲ, ಅಥವಾ ನೀನ್ ಲಾಗ್ ಔಟ್ ಮಾಡಿ ಲಾಗಿನ್ ಮಾಡು, ಸೆಟ್ ಆಗುತ್ತೆ. ನಿನ್ ಹೆಸರೇನು?
ಮೊಹಮ್ಮದ್ ಖಲೀಲ್.
ಮೊಹಮ್ಮದ್ ಖಲೀಲ್. ಖಾಲಿದ ಖಲೀಲ?
ಎಲ್ ಖಲೀಲ್.
ಖಲೀಲ. ಓಕೆ, ಮಾರ್ಕ್ ಮಾಡಿದ್ದೇನೆ. Now we shall go with the derivation of the actual Brayton cycle. Okay. So pretty much the same thing, but the thing is, you'll be having the values of NC and NW in case of the actual Brayton cycle. Okay, take down this expression and draw the PV diagram of an actual Brayton cycle. Ideal Brayton cycle ali 2-4- irolla, but actually 2-4- ಬರ್ತವೆ. There is a deviation in actual, but there is no deviation in case of an ideal. ಈ deviation ಬಂತು 2-4- ಬಂತು ಅಂದ್ರೆ it is an actual thing. ಆನಂದ, shall we start, or you are still drawing the diagrams? Shall we start the derivation?
No, sir.
Okay. Draw. Shall we start?
Yes, sir.
So same thing again, W net. You calculate the value of W net. Again, there are only two work done. Same case. So it is WT plus WC. So I will be writing directly it is CP into T3 minus of T4 plus CP into T1 minus of T2. Considering for, I would just write it here, considering it for unit mass. Next, by definition of efficiencies, by definition of efficiency of compressor and turbine, we have what we have is this. I will just take that same thing once again. So by the definition of those, we have this particular thing. Okay. So from this, can I write it as T1
Sir, can you zoom up?
zoom out? Taking this here and this, can I write it as T1 minus of T2 is equals to efficiency of a compressor into T1 minus of T2 dash. Can I write it as such? Similarly for the turbine, T3 minus of T4 is equal to 1 divided by efficiency of the turbine into T3 minus of T4 dash. Can I write it? Can I write as such? T1 minus T2 and T3 minus T4 using efficiency of turbine and compressor. Can I?
Yes.
Okay. Now, substituting the same in equation number 1. Substitute the value of T3 minus T4 and T1 minus T2 in that particular equation. So what we would get is this. So W net is equal to Cp into T3 minus T4 dash divided by efficiency of turbine plus efficiency of compressor into T1 minus of T2 dash. Right? Is the substitution correct? T1 minus T2 dash, T1 minus T2.
Yes, sir.
Correct? Now, what I'll be doing
Yes,
is
sir. Yes, sir.
Cp into T3 minus of T4 dash divided by efficiency of the turbine. Idana minus ಮಾಡ್ತಾನೆ. So minus ಮಾಡಿ, I would write it as T2 dash minus of T1. Okay. Now again the same thing. Last time ಏನು ಮಾಡಿದ್ರಿ ಇದಾದ ತಕ್ಷಣನೇ you have taken T3 common, no? Same thing you have to do here also. Write it in terms of temperature ratio. Okay. W net is equal to Cp into 1 divided by efficiency of the turbine into, ಈಗ ನಾನು T3 ಕಾಮನ್ ತಗೊಂಡ್ರೆ ಒಳಗಡೆ ಏನಿರುತ್ತೆ 1 ಬರುತ್ತೆ ಮತ್ತೆ T4 ಡ್ಯಾಶ್ ಡಿವೈಡೆಡ್ ಬೈ T3 ಆಗುತ್ತೆ. ಕರೆಕ್ಟಾ? ಮೈನಸ್ efficiency of compressor into T1 common ತಗೊಂಡ್ರೆ it would be T2 dash divided by T1 minus of 1. Now, again by the definition of temperature ratio, PR, we have TR is equal to T2 dash. Now it is dash, no? Have to take it as dash itself. So TR divided by T1, that is equal to T3 divided by T4 dash. For actual, you should always consider that dash. Okay. Next. So just write it there. I would write directly W net is equal to Cp into 1 divided by efficiency of turbine into T3 into 1 minus, see T3 by T4 dash is TR. So can I write it as TR to the power of minus 1? ಕರೆಕ್ಟ್ ಉಂಟಾ ಇಲ್ಲಿವರೆಗೆ? ತಪ್ಪಿದನ ಕರೆಕ್ಟ್ ಇದನ?
ಕರೆಕ್ಟ್ ಇದೆ.
ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡಬೇಕು? ವಾಟ್ ಇಸ್ ಅವರ್ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್? ಸೇಮ್ ಲಾಸ್ಟ್ ಟೈಮ್ ಏನ್ ಮಾಡಿದ್ವು ಅದೇ. ವಾಟ್ ಇಸ್ ಅವರ್ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್?
W net is equal to B divided by.
Exactly. So condition for, you have to apply the condition for maximum specific power output. Maximum specific power output. ಏನು ಹೇಳ್ತದೆ ಆ ಕಂಡೀಷನ್? ಸೇಮ್ ಕಂಡೀಷನ್ ಬರೀರಿ. So it says d by dtr of w net would be equal to 0. Right? Now, so w net ಇಲ್ಲಿ substitute ಮಾಡ್ರಿ d divided by dtr of w net. What is w net? Is this whole thing. Okay. Is equal to 0. ಸಾಲ್ವ್ ಮಾಡ್ರಿ ಪಟ್ಪಟ. ಸಿ ಪಿ ಆಚೆ ಹೋದ್ರೆ ಹೋಗುತ್ತೆ ತಾನೆ? ಸಿ ಪಿ ಡೈರೆಕ್ಟ್ ತೆಗಿಬೋದಲ್ವಾ? ಸಿ ಪಿ ಹೋಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಏನು ಉಳಿಯುತ್ತೆ ಅದೆಲ್ಲ ಬರ್ಕೊಳ್ಳಿ. 1 divided by efficiency of the turbine into T3 into differentiation of 1 is 0 minus direct ಆಗಿ ಬರೀತೀನಿ. ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಪ್ಲಸ್ ಆಗುತ್ತೆ. TR whole to the power of minus 2. ಕರೆಕ್ಟಾ? Correct me if I am wrong, man. Okay. Minus efficiency of turbine into T1 to 1 minus 0. ಕರೆಕ್ಟ್ ಉಂಟಾ ನೋಡಿ? ನೆಕ್ಸ್ಟ್ ಎಂತ ಮಾಡೋದು? T3 divided by efficiency of the turbine into TR whole to the power of minus 2 minus of efficiency of compressor into T1, that is equal to 0. Now TR to the power of minus 2 is equals to efficiency of compressor, efficiency of turbine into T1 divided by T3. Correct? T1 ಆಚೆ ಹೋದ್ರಿಂದ T1 divided by T3. ಕರೆಕ್ಟ್ ಉಂಟಲ್ಲ? ಸೊ ಈಗ ನಾನು ಅದು ಮೈನಸ್ ನ ತೆಗಿತೇನೆ. ಸೊ TR is equals to efficiency of turbine, efficiency of compressor into T3 by T1. So when I apply and derive for TR based on the condition, can I call this particular thing as TR optimal? Because I have applied the condition.
Square.
ಏನಪ್ಪ? ಸ್ಕ್ವೇರ್ ಅಲ್ಲ, ಕರೆಕ್ಟ್ ಕಣ. ಆ ಸ್ಕ್ವೇರ್ ನ ತೆಗ್ದು ಇಲ್ಲಿ ಹಾಕ್ಬಿಡ್ಲಾ?
1/2.
ಫುಲ್ ಆಗುತ್ತಲ್ಲ ಅದು, ಇನ್ಕ್ಲೂಡಿಂಗ್ ದಿಸ್ ಎಫಿಷಿಯನ್ಸೀಸ್ ಆಲ್ಸೋ ಅಲ್ವಾ? ಈಗ ಕರೆಕ್ಟ್ ಉಂಟಾ?
ಹಾಗಾದ್ರೆ ಎಫಿಷಿಯನ್ಸಿ 1 efficiency of C into 1 efficiency of T.
ಏನು
ಸರ್ 1 ಆಗ್ಬೇಕಲ್ಲ, ಅದು ಡಿನೋಮಿನೇಟರ್ಗೆ ಹೋಗ್ಬೇಕಲ್ಲ ಎಫಿಷಿಯನ್ಸಿ.
ಯಾವುದು 1/?
ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ಸಿ ಮತ್ತೆ ಟಿ.
ಡಿನಾಮಿನೇಟರ್
ಅದೇ
ಮೈನಸ್ ಮತ್ತೆ ಪ್ಲಸ್ ಚೇಂಜ್ ಆದಾಗ.
No, these are efficiency values. These are constant values. ಅದರಿಂದ ನಿನಗೆ ಏನು ಎಫೆಕ್ಟ್ ಆಗೋದಿಲ್ಲ. Only we are concentrating on T3 by T1 ಅಷ್ಟೇ. ನೀನ್ 1 efficiency of compressor efficiency of turbine ಆಗ್ತದೆ ಅಂತ ಮಾಡಿದ್ಯಾ? ಅಲ್ಲ ಆಗೋದಿಲ್ಲ. It's only for T1 and by T3. These are efficiencies ಅಷ್ಟೇ. Okay? Clear ಆಯ್ತಾ?
ಸರ್.
ಅಗೇನ್ ಲಾಸ್ಟ್ ಟೈಮ್ ಮಾಡಿದ ಹಾಗೆ ಅಗೇನ್ T3 by T1 is TR, and TR is equals to beta to the power of gamma minus 1 by gamma. Suppose ನಾನು TR ಗೆ ಏನಾದರೂ ಆಪ್ಟಿಮಲ್ ಹಾಕಿದ್ರೆ ಬೀಟಾ ಕೂಡ ಏನಾಗುತ್ತೆ? Optimal ಆಗುತ್ತೆ. So now TR optimal, I can write it as beta optimal to the power of gamma minus 1 gamma minus 1 by gamma, that is equals to efficiency of compressor, efficiency of turbine into T3 T3 by T1 whole to the power of 1 by 2. Last final expression ಏನು ಮಾಡಬೇಕು ನಾವೀಗ? Beta optimal is equal to efficiency of compressor, efficiency of turbine into T3 by T1 ಏನಂತ ಬರ್ಕೋಬಹುದು? Can I write it as TR? So gamma minus 1 by gamma ಆಚೆ ಕಳಿಸಿದಾಗ ಏನಾಗುತ್ತೆ?
Gamma by gamma minus 1.
So it is gamma divided by 2 times of gamma minus 1. 2 already ಇತ್ತು ಕಾರಣ. Now just put it in a box and close your derivation. Okay. I'll just write the sentence. Is the required expression for optimal pressure ratio for maximum specific power output of a ಯಾವ್ದಿದೆ? ಐಡಿಯಲ್ ಆಕ್ಚುವಲ್ ನಾವು ಡಿರೈವ್ ಮಾಡಿರೋದು
Actual.
So it is actual Brayton cycle, and there ends your total derivation part in this particular module. ಅರ್ಥ ಆಯ್ತಾ? ಏನಾದರೂ ಡೌಟ್ ಇದೆನಾ?
No, sir.
Sir, which more?
ಏನಪ್ಪ?
Module.
ಏನ್ ಮಾಡ್ಯೂಲು?
ಎಷ್ಟನೇ module sir?
ಓಯ್, ಮಾಡ್ಯೂಲ್ 2 ಇದು. Okay, so in the next class we'll be discussing about few another concepts, how you can increase the efficiency of this Brayton cycle. There are 3 methods: regeneration, intercooling, and reheating. All 3 methods we'll be discussing in the next class. Okay, thereby how to you increase your efficiency of a Brayton cycle, and then we will move on with the problems. Okay, so in the next particular class we'll be starting the problems also. Okay, is that clear?
Yes, sir.
Yes.
Okay, so all of you have marked your attendance, I guess. So stay at your homes, be safe. Okay, we'll meet up in the next class. Enjoy your remaining hours. Thank you for the day. Anish,
So one problem is there, sir.
what is the problem?
So wait,
Okay.